Hello everyone, welcome back. So in this video we are going to understand 3625 Leetcode problem, and this is the last question of weekly contest for 59, right? And the very first version of this problem we have already uploaded, so I'll keep the link into the comment section. You can go and you can watch from there. Okay, so let's understand what the question is saying here. Question is saying that we are given a 2D integer array that is called points, where points at I is nothing but a given coordinate system point in the Cartesian plane. So I will not talk much about this because we have already talked so much thing in this version of 1, right? Version 1, and this is version 2. So I'll not go in the deep like what is Cartesian plane and what is trapezoid, right? You can go and watch that link so you can understand what is this. Okay, and it will be good if you watch the first version of video, right? So you can understand, you can relate that what is the differences there, and you will have the better understanding of a lot of concept there. Okay, so I'll suggest please pause this and go and watch that. Okay, and if you're regular in ExpertFunda, so you will you can continue. So let's understand what are given here. So we have given points as you can see in the example. So each point contains x and y value, means this is x1 and this is y1, right? Can we say that x1 y1 x2 y2 x3 y3, like that? We have all the points we have given in the points array. So this points is nothing but a 2D array, and that is why it is saying at each index at point of I, point at I, we can say index at I represents x1 like xi and yy, means there is some points. That point is called ith point on the Cartesian plane. We have to return the number of unique trapezoids. What is trapezoid? You know that, and can be formed by choosing any four distinct points to form or not. So let's understand what is trapezoid. Also we'll discuss in the further in the video. Don't worry, just understand we have to return the unique trapezoid that can be formed by choosing any 4 points from the given points. Means to form a trapezoid, how many points we need? At least 4 points we need to form it, right? So we have given, see, 1 2 3 4 and 5. So these 5 points we have given. Out of the 5 points you can choose only 4 points and you can make the number of trapezoid. So this point can be anything. For example, if you come here, right? So if you observe that from the given point, let me zoom out, right? So if you can see the example 1 given points, these are the points. So if you'll take, if you put these values here, right? Let's suppose we are putting -3 and 2. So when y is 2, 3 is at what do you call, x is at -1, means we are talking about this point. Can we say that? Give me a second. So if we will point these values, right? So very first point is -3 and 2. So this is nothing but your -3 and 2. When y is at 2, we can say this. When y is at 2, we can say this point, right? Means x is going in the minus form. Means in this, no, sorry. How can I make the here? Okay, this point. So x in the minus this direction, right? This direction, and y in this direction, correct? So minus x means -3 and 2. So we can say this is your -3 and 2. Then we have 3 0, means 3 should be at this point, right? And y is at 0, means let's suppose 3 is at where? At x. So we can come here, and y is here. So this another point we have given as a 3 and 0. Then we have 2 and 3, right? So when x is 2, let's suppose this one, so we'll go here and we'll mark it as a 3. So we can say when at 2, we can say this one, means at 2 and 3, this one. And then we have 2 and -3, so we can say this one, 2 and -3. So if you observe that we have discarded this 3 0 in this, right? And then we have formed this array. Similarly, if you observe here, we are discarding this one this time, right? And we are forming this array, this trapezoid. Okay, just all the point you just see, only this point we are not considering, and then we are forming the trapezoid 2 trapezoid. So out of that 5 points is there, we have to choose 4 points to form the trapezoid, right? Trapezoid is either this one or this one. These are the directions. We can say at least 4 points we need to form the trapezoid, right? And that is why if we choose either this or this, we are discarding. It means we are forming only two trapezoid here, and that is we have given in this example, right? Similarly, if you come to here and if you see the another point, we have given these points, right? We put 0 0, so you can say this 0 0, this we have 1 0, like that we have given, right? 1 0, and it is forming only one trapezoid here. If you discard any of these, you cannot, because see, these are fixed values, right? As you can say, and then we can form, then there is how many points we have given? Only 4 points we have given, right? And that is fixed. At least you need to form the trapezoid, 4 points required. Only 4 points we have given, so only one trapezoid we can form that. I think you understood the problem. So let's understand the constraint also, because we need that. So it is saying points dot length is the given points can be greater than or equal to 4, and means at least 4 will be given, and it should be less than equal to 500, and x1 and y1 can be minus 1000 to 1000 between the range, and all points are pairwise distinct. So we'll understand through the slide, so you will understand the questions, problem statement, and the approaches. So let's continue to understand this problem 3625, count number of trapezoid, right? So the very first question is saying that we are giving a list of points on a 2D Cartesian plane, and our goal is to count how many trapezoid we can form from the given points, right? So each trapezoid formed by choosing 4 points. So for example, like this, we need at least 4 points to form the trapezoid. So what is a trapezoid? Trapezoid is a quadrilateral 4-sided polygon, right? If you see, there is a 4-sided we have given, where at least one pair of the opposite is parallel to each other. Like this is parallel to this one, right? Can we see that? Or there can be more than one are parallel, like this can be also parallel. So let's say we have given points, we have given a points, like 4 points we have given, A, B, C, D, right? These 4 points we have given, and all are, let's suppose, is parallel. So in this case, let's suppose AB and DC are horizontally, right? This is a horizontal, this is horizontal. So these two horizontal lines form the what you call parallel lines, right? In the same slope. This is, and this is in the same slope, right? So they have the same slope, and so we can say they are parallel. So let's suppose for the AD and BC, can we say that this is also parallel to each other, right? We can say that because it's also having the same slope, right? So this shape is trapezoid, we can say that, and it is also kind of, it's a parallelogram, we can say that. Okay, if both pair, this one and this one, are parallel, then it is a parallelogram, we can say. So let's understand the points. If we have given these points that we have seen, right? So if you visualize these points over this, so we can say the very first, you have already understood this is forming the points that we have seen, right? And this is if we are discarding. Let's suppose for this case, if we are discarding this point, means we are discarding, what is this point? Is 3 0. If we are discarding the 3 0, we can form this one. If we discard this minus 3 and 2, means these points we will discard, then we can form this. Means out of these points, right, we can take 4 points and we can form this and this. Means two what you call, two trapezoid we are forming, right? So always, if you have given, try to visualize all the combinations of the points and try to form the trapezoid, and then list out of how many you are forming that, right? So some will be a quadrilateral, some will be a trapezoid, right? So some of those who have at least one pair of parallel side, at least one pair, so we can say that is your trapezoid. For in this case, you can see this line and then this line is parallel to each other, so it is trapezoid. For this and this, it is parallel, so this is trapezoid, right? And if all are equal, that can be, if this is parallel to this one and this is parallel to this one, so this will become a parallelogram, right? So how to detect parallel lines? First of all, so we have to use the slope formula. If you remember, if you want to find the slope of the lines between, let's suppose there is 2 point A and B, right? Can we say that? So if we consider that we have a line between these 2 points, right? These two coordinates plane, x1 and y1 and x2 and y2. How we are making the slope? By y2 minus y1 divided by x2 minus x1. With this formula, we used to find the slope. So if two lines have the same slope, they are parallel, right? So what is our goal? We have to find how many sets of 4 points form a trapezoid, right? And that many sets you have to return it, right? So what is the challenges here? We can try all the combination of 4 points directly. That would be O of n 4, right? Because out of 4 we have points, means all combination of 4 points we have to check, right? And that would be slow if we will having a large volume, like we have given almost 500 around, right? And the points is around 1000 to 1000 minus 1000 to 1000 we have given, right? So it will become a very you can say slow the solution. And so instead of using all the trying all the combination of the given points, right, what you can do, we can use a pair of points, that is called line. If we can find two lines that are parallel, right, but not the collinear, understand? So the solution is we loop through all the pair of the points, and this will give us all the possible lines. So for each line we'll calculate its slope and it intercept, where it intercept, right? We'll calculate the slope and intercept. So if another line has same slope and it's parallel, the same slope and intercept, it's a collinear, so we will skip it, right? And then we'll check how many ways we can pick two non-collinear and parallel lines, they can form a trapezoid. And we can also exclude the parallelogram which form counted twice. Okay, so you pause this, understood what we are trying to say? Means very first what we need to do, we have to loop through all the pair of points, right? That is our all possible lines, right? So for each line you have to calculate slope and intercept. Intercept means where two lines what do you call connects, right? You can say, or cut. If another line has, right, if another line has but same slope, means it's a parallel, and same slope and intercept is a collinear, right? Means how many ways we can pick two non-collinear and parallel lines, and that is forming the trapezoid, right? And we have to exclude this parallelogram. So let's understand the code and then we'll understand how to implement it. So let's understand example. So we can try the four points. Let's suppose we have a points. Can we write a points, and we can say these points can be, let's suppose we have very first point is 0 0, then we can take 1 0, right? And 0 0 1 0 we can take, and 0 1 take, and another we can take 1 1. Let's suppose these 4 points we are taking, point 1, point 2, point 3, point 4, right? So we are trying with these 4 points, right, that we have understood the approach, right? So what we can do, just form a square, right? How we are going to form? For Cartesian plane, let's suppose the very first point, this one, is nothing but, can we say 0 0? Let's suppose I'll write just like this. Okay, you just think, if I'll say this one is 0 0, okay, then I'm going to connect with the 1 0. Can we say that this is 1 0? If I'll consider this as a x-axis, right, and y-axis, and this is your x-axis, we can say that, right? So here give me 1 second. Okay, so I can take, we are forming this, and let's suppose I'll form like this. So can we say that this is your 0 0, then what we have 1 0, right? And then this point is, and this point we have to find, this is your u1, and this is your nothing but 0 and 1. Understood? So these points we have given. Okay, so we form the square. Now understand, if we'll name it as, let's suppose A, B, C and D, can we say that if these are the points we have given, so can we say that A, B and C, D, these two are horizontal, from A, B and C, D, these are horizontal, means these are horizontal. And so what is the slope is there? So slope is, for the horizontal line, is nothing but 0, means when slope is 0, we'll say this is parallel, right? Can we say that? So very first point is this. Next understand, if we have AD, we'll understand this one and this one, so both are vertical, right? AD and B C, right? Those are verticals. So can we say that here the slope will be what? It will go, we'll say infinite. Let's suppose we can take infinite. Let's suppose this slope is infinite, right? So we can also say this is also parallel. Either you can take 0 or this one, right? Slope. If slope is either 0 and infinity, means let's suppose is a going till very far, right? So can we say that either 0 and 1, in both cases it become a parallel, because the parallel lines never meets. Understand? So either 0 or 1, we can say, let's suppose we will say infinite also. So either it is 0 or infinite, in both cases it never meets. If never meets, means these are parallel, right? So this is become what? Parallelogram. Can we say that this is your parallelogram, right? And then we can say we have to count twice. We have counted twice, remember, in trapezoid logic. Trapezoid logic. Okay, so if we are considering these points, right? So in this we have ABCD and ADBC, both are parallel, and so we can say these forms are nothing but a parallelogram, and it counts what? Twice in trapezoid logic. Oh, the parallelogram. So with this logic, can we say that we will subtract one parallelogram, right? Let's suppose from this parallelogram, if we'll subtract one parallelogram to avoid the duplicate counting, right? If we'll avoid the duplicate counting, means we are good to go, right? It means, can we say that give me a second. Can we say that if it is parallelogram, right? If it is parallelogram, then we are counting twice. So what we will do, just return the trapezoid count. Let's suppose trapezoid count. Can we say trapezoid count? And then we'll do what? Parallelogram count by 2, right? We'll take trapezoid count and parallelogram count divide by 2, right? If we'll do this count and this count, right, and divide by 2, so we'll return the final output. So trapezoid is equal to what? We can say that is a quadrilateral. If you'll divide by 2, means quadrilateral with at least one pair, means parallelogram. Let me give you here. So what I'm trying to say here means, can we say that trapezoid, right? You check the spelling, okay? So trapezoid is equal to what? Quadrilateral, okay, with one at least one what do you call a pair, right? So this pair is what? The parallel lines, right? The parallel sides, we can say. At least one side if we will choose, so it is equal. So if we will count how many unique pair of lines from point pairs, right? So there will be either parallel or either non-linear, right? Non-linear means this has the same slope and this has a same slope with the intercept line. So we have to skip this one, right? So if we'll combine this, means combine into this, so it will make what? 4 points, and that is your trapezoid. Can we say that? Are you understanding, right? What I'm trying to say, I'm saying trapezoid is equal to quadrilateral with at least one pair of parallel side, right? And if we will count how many unique pair of the lines we have, means the given point pair we have, right? From there, either it will become a parallel with slope, we can say same slope, with the same slope. For that it will be parallel. If it is not parallel, it is non-linear, right? Here it will be the same slope, but there will be intercept is also there, right? Intercept is also there, and so this become the same line, and so we'll skip it. Just visualize yourself, right? You will understand. Then we will combine these two, Once you will combine these two into 4 points, that will form the trapezoid, right? And then we'll subtract the parallelogram to get count twice. Understand? Finally, what you need to do? You have to subtract, right, the parallelogram. So you will get the count twice. I hope you understand, right? Let's understand the code. So here, if you observe, right, very first you have to find the trapezoid parallelogram, right? So there is other parallel lines and collinear lines, right? So some periodic questions you have to do. Let's suppose you know how to find the GCD, how to do the has. So these things you have to understand, right? Because these are the helper method. So GCD used to compute the GCD of two integers, right? And this is your has function that will normalize a fraction a by b. If you'll do that, will handle the scope or intercept, we can say that. Okay, then we have our count trapezoid method. So we can say it will have a, we will providing the argument points. From there you will get the number of points. So we'll calculate the trapezoid parallelogram, right? So we have to create a HashMap to count lines by the scope and slope plus intercept, that we have understood right now. Okay, so it will detect the parallel and the collinear lines, right? So for the parallel lines we'll create this one, and for the collinear we'll create this one. So these two map we will create so that we can count the lines by their scope and the scope plus what you call intercept, right? So next step, what we need to do, we have to loop through all the pairs of the points to count the trapezoid, right, and the parallelograms. Okay, so very first you will iterate through all the given points. From each points you will get the point, let's call it p2, and there is another will take j, right? And for that we'll take, because we have to take the combination, so p1 and p2 will take, and for each p2 we'll go for all the p1, right, we can say, or we can say for all p1 we will go to the p2. Just reverse it. So what will happen, very first you will compute the slope as a reduced fraction, and you have to use this has function, right? If it is coming, fine, otherwise it will by the infinity. So you will get the slope, right? Slope either it is, if it is not equal to, you will check the has function, right? It will give you some value if it is not equal. If it is not equal, means it will go to infinity, means it will become a parallel, right? Means the slope will get what? Infinity. You know, the if slope is infinity means what will happen, this is a parallel, right? Similarly for the intercept, you will check, you will compute the intercept, right? If it is intercept we are getting some value, means it is not parallel, it's a collinear, right? Then we will have a scope key. So you will create a what you call key to store into the what you call in the map. So this is the parallel lines and this is the collinear lines. So on both, what you will do, you will get the, if you have already the lines are there, right? How many lines are already in the there? So you will see scene parallel, scene collinear. You understand the HashMap, right? From there you will get the scene collinear, scene parallel, right? Both we will get, and just you need to do what? You do the subtraction. Once you will do the subtraction, you will get your trapezoid, right? Parallelograms, right? And then you will update the map with the current. So this is your current key, and will keep increasing the with the +1, right? It will increase the frequency of the with the key, right? And finally now we will get the parallelogram, right? To get the parallelogram you will do almost same thing, right? Like you will calculate the scope, you will get the intercept. Similarly you will check the distinct, means we will check the distance between the points, we will compute. Then similarly we will get the keys, right? And you will get the scene, both scene, like the parallel scene and the collinear scene you will get. And then you will increase your count each time, just double the difference, right? And you will update the maps, you just increase it like a frequency we are increasing, right? And finally to get the result, you'll get what? Trapezoid parallelogram minus this one by divide by 2. So you will subtract the duplicate parallelogram, so you will get counted twice. For each counted twice you will just do minus this one, right? Means what we need to do, because we are combining into four steps the trapezoid, so we'll subtract the parallelogram so we can get counted twice. Okay, and this will be our output. So thank you guys. If you still have any doubt, let me know in the comment section that you have doubt or not. If you have any doubt, let me know so I can help you in the comment section. And please subscribe this channel and support ExpertFunda in case you have not subscribed, right? And please hit the like button so more viewer will get the benefit of this video, and ExpertFunda directly and indirectly will get supported by you as a good viewer. Thank you guys. Thank you for watching this video.